All right, kids, let's get started. So, we'll talk about the most boring thing about NLP first. I hope I don't bore you away from this class. It's about text processing. So this is to review some of the programming concepts that you have learned from Comproc as well, okay? So text processing. Oh yeah, what is a text? What does text look like? Yes, text are strings. Yeah, text are string. Great. And why are we interested in text? Why do you want to do things with it? What's in it? What's in them? That's how we convey senses through language, yeah. And you said information, right? So text has information. So that's why we want to work with it, okay? So text, right? NLP is about AI for text. And we need text because we want to study certain linguistic phenomena, like how people express their opinion, how people talk, how people answer questions, how people summarize and translate, okay? And also to create an NLP application, we need some text data for the machine to learn from. That's why we need to work with text. So it's a very important component for any NLP system, although we never see it. But when we develop a system, as an NLP system developer, we have to work with text a lot, like all the time, basically. So text, a collection of text is also called a corpus, okay? And the plural of this is not corpuses, it's corpora, okay? Corpora, it's a beautiful word. Not corpora either, you know. Some native speaker will call corpora, like tempura, you know, but it's corpora, okay? Say it right, and you're gonna sound really cool. So, corpus, okay? A corpus is a collection of texts. Collection, that means somebody collected and put into one place in certain way. So when you talk about corpus, we talk about a group of texts, a collection of texts that are produced by some group, consumers, Facebook users, translators, or what people say to the chatbots, okay? Those are specific group of authors, but sometimes a single author, all right? And usually of a specific language or dialect from specific time frame, place, for a specific function. So that's why we separate corpus and text, okay? So corpus is something that we already organize and put together into one thing, all right? So, but sometimes we just call it a data set, okay? But data set is a broader thing, right? Because data set could be, you know, numbers, stock prices, scores, it can be any other thing. So in NLP, we call it a corpus. Or you can call it a data set. You know, there's no harm in that. All right, to get the terminology out of the way. What does text data look like? Look like strings, and strings with different flavors, right? Because we don't have just English. The first, what's the language of the first line? Oh, French. Oh, you can recognize French. Awesome. Okay. It's such a rare language to learn nowadays. Back in my days, when it was at Thermodome, it's quite popular, but now people want to learn other languages. Second one is Thai, obviously. The third one is traditional Chinese, I believe. I think it looks messy. It must be traditional Chinese. Yeah. So the fourth one, English, and the last one is Japanese. Okay. So we have many writing systems, and thankfully, a string, our favorite data structure, can encode any writing system. So that's awesome. And text nowadays also, I should add as well, there are other things like symbols, emojis, numbers, right? So that's also called part of the text, because we use emojis a whole lot more nowadays, now that we have many other ways to express feelings. All right, so we need to process the string somehow. Why do we need to process the string of text? Because we want to make an NLP model understand it. So how do we get there? So text data has their own issues, all right? So the first one is noise. So that means it's always dirty. No matter where you get the data from, it's always dirty somehow. Did you guys take data science last year? Right? So yeah, just like data science, who wants to clean data? Nobody, but it's like 80% of your work, right? Usually when you do it in a project setting. So yeah, we'll talk about noise first. Noise. So when you talk about noise, things that make the data dirty, it usually, we have to talk about the source of the data. If it's already in a beautiful text file, it's great. If it's from PDF files, maybe not so great because you have to pull the text out of the PDF. Not very easy to do. You can throw it into ChatGPT, it will pull the text out, but it still makes some mistakes, okay? Especially if it's a Thai text, it will make a lot of mistakes because Thai text is quite special. So today we'll talk quite a bit about Thai text, all right? And the next source is actually a very important source. It's the internet. The internet has a lot of text data that we could use. Let's talk about the internet. Usually it's from some API calls, right? So you have some API, you get some text back. Usually, if you get the data from API, it's usually okay because you might pay for it. Say, some Twitter API, Facebook API, you pay for it, and then you get, some strings back. Usually quite clean. But if you scrape, so you write some regular expression to scrape data from the web page, sometimes it gives you HTML tag as well. So you have to clean those. So either way, no matter what the source of the data is, there's always noise. Look at this. Look. Sorry, I just realized there's some non-Thai speaker. I'll in the future, I'll have some English data as well, all right? So look at the sample from on the left. There's text, then there are also other things that we don't want, right? For example, what is this? It's a retweet of, and this is handle name, it's not even text at all, right? That's a URL, and that's I think that's when you share a link over to X, right? You get something like this. And it's also cut off because if you don't specify certain parameter in Twitter API, it will give you not the whole thing. So this is what I meant by dirty. This is dirty, right? So we have to clean that up. Okay? Here as well. So what's wrong with this one? What is this one? 3/3. Are you guys on Twitter? Say again? On the other side of the world? On the other side of Twitter. Anyways, so when you see things like this, sometimes because Twitter used to have character limit, right? So they break it in two parts: 1 out of 3, 2 out of 3, 3 out of 3. So you get something like this as well. So you need to stitch them back together if you want a complete text, right? This is also real thing. This is created from a news website. No, this is from the news website. This is from Twitter. You got the typo. That people, intentional or not, they will have some typo in here, right? And this is what? HTML tag. So that's just what I meant by dirty. So we have to clean all that up, right? So yeah, so we have to do a bunch of things, clean out the non-text portion, the link, the URL, HTML tags, the number, the hashtag, if you don't want the hashtag. And you have to decide as well if you want to include other languages too. So if you want just English tweets, then you have to screen out all other languages, okay? All right, if you want to remove all these things that I mentioned, say retweet, what tool should we use? It starts with an R. Second letter is an E. Regex, thank you, regular expression. And do we know regular expressions well? Yes. Oh, okay. So we'll talk about regular expressions then, if you don't have 100% consensus. Should we talk about regular expressions? Okay, a little bit. Okay, a little bit. Okay. It's so weird, regular expression. When I was, a bachelor student, nobody taught us regular expression until I take NLP. It's something that computer science never teaches you somehow, okay? So it's great to know regular expression. Regular expressions is often referred to as regex or regex. Up to you. Regex or regex, but I prefer regex because it's regular, not like jeweler, right? So I like regex, okay? So you can say regex if you want, or reject in Thai, right? Reject, right? In Thai, yeah, Thai people call reject, which I refuse. Okay, regex is a language used to specify and match patterns of characters. So for example, sometimes you want to search for things that are quite complicated. So say you want to search for phone numbers that have 10 digits, where the first digit must be 0, remaining 9 can be anything. But if there are 9 digits, the first digit doesn't have to be 0. So, things like this. It's hard to write a program to detect this, but regular expression is probably the only way to express that, all right? Email addresses, we use that a lot when you create a form and you want to check whether it's a real Gmail, no, not real Gmail, real email address or not, then you use regular expression. So say you want to find email addresses of government employees, so which means anything before @ symbol, any English letters has dot or numbers, but after it has to be anything but ends with .go.th. These are so complicated just to talk about, but there's a language to express that because doing it in English is terrible. Again, nowadays you can use ChatGPT to write regex for you, but it's good to know from like manual perspective too. If you want to search for Thai language organizational abbreviations, so acronyms like MOT, OSO, MOT, BOTT, for example, all these acronyms, how do you, so the language, the pattern is 2 to 4 Thai characters followed by a dot. Okay, it cannot be vowels, right? There cannot be vowels, there cannot be tone markers. So yeah, these are some examples that we use a lot, and it's almost impossible to write a program without regex to express this. I might go a little fast on this one, assuming. So raise your hand if you have seen regular expressions before. Okay. Didn't you guys take all the same courses? All right, let me cover it in a normal pace then so that we are on the same page. Yeah, it's first day after all. So if you already know it well, it'll be a review. Okay, so regular expressions, they are quite compact because it only uses just symbols strung together, all right? So there are 4 types. There are literal characters, meta characters, grouping characters, and quantifiers. All right, first, literal characters. So it's basically just character. A is an A, B is a B, gõ gai is a gõ gai, all right? These are literal characters. So anything on your Unicode chart, which means any language, including emoji, all right? So it encodes the mapping between, well, you know what Unicode is, I'm sure. But there are some characters that you have to escape. We call it / escape. So if you want a pattern that has a plus sign, you have to escape it. And also, I left one out, dot as well. So dot, yeah, you also have to escape it. So for example, if you want the pattern that match www.jula.ac.th, you need to escape the dot, okay? And any of these characters, so this is a common mistake actually, because these mean something else in regex, so you have to escape it, escape from their usual meaning, all right? Oh, speaking Thai Unicode, so Unicode looks like this, right? So you have some base 16 hex code right here, so 0E0X, so 0E01 is a gõ gai, okay? 0E1A is a bó bei mai. All right, so this is a Unicode chart for Thai, and it actually has all characters. Also, what's this thing again? It has some like cute name to it. I don't know what it's called. And this is like a Fong Man. This is a Nick Kahit or something. You know, some Thai weird characters that you don't really see much at all. All right. And this too, the baht, the Thai baht sign is also in this group. And there are some spots for no reason. It's not used to encode any Thai character. So it's grouped together. That's all I want to say. So next, meta characters. So if you want to specify a pattern, so you want one character to represent some set of characters. So for example, a dot, it means any character, like anything, okay? \w is word character. Word character means A to Z, small a to Z, big A to Z, 0 to 9, and underscore for some reason. So other symbols are not included because they're not part of the word, all right? And special for Python, in case you code in other languages, if you code in TypeScript, it might be a bit different. But for Python, good news, \w can also means gõ gai to hò no hook, I believe. Not sure about the vowels, I have to check. I think the vowels are in there as well, yeah. So next, big W. Big W means not, the negation of W. So anything that's not \w. All right, usually it means spaces or whatever symbol characters. D is digit, 0 to 9. Big D means anything that's not digit. So you can think of the capital letter as the negation of the small letter equivalent. S means space, it means white space, but it doesn't mean just the space. It also means \T, which is the tab. Once you press the tab, you add some space, right? That's also included in \S. \N is new line. So when you have a text file and it has a new line, it's \N, okay, special character. And some old Windows systems still use \R. It's also included there. \S is the negation of that. B is word boundary as defined in English. So usually it's \S as well. We don't use this very much. And the caret, we call it caret, all right? C-A-R-A-T, caret. But some native speaker would thought it would be like carrot, like the vegetables, because they didn't know it's a different word, but it's pronounced the same. It means beginning of the string, all right? And dollar sign is the end of the string. You can always look this up. I sometimes forget too. Is it the W? Is it the S? You know, but yeah, knowing some of these would be very useful. All right, let's do some exercise. Suppose I have this regex, ddd dash ddd dash ddd, and for each of the following string, I want to think whether it matched the whole thing, or part of it, or it doesn't match at all. Okay? The first one, entire match, partial, or no match? Entire string, right? Okay, because it followed this pattern exactly, although it's all different numbers. Number two, it's a partial match because the last guy, right, doesn't really belong to this pattern because you use already all the digits here. And the third one, it's partial, just this part, right? All right. And the fourth one, also partial. Okay, great. You're doing great. Next one. What about this? Caret means beginning of the string. The dollar sign means the end of the string. All right? All right, same question. The first one, that's the exact match, right? Entire string match. Number two, everybody agrees? No match? Yeah, no match, because we require that at the end of the last digit is the end of the string, but we don't get the end of the string, so it won't match at all. All right? What about the third one? No match as well. Awesome. Exercise 3, let's go. What is this thing again? What is it called? Escape. Okay, so escape dot means it's actually a dot, a literal dot, okay? So the first one is a match or not. Do you remember what the backslash W means? What does it mean? Small characters? Okay, it means word character, right? So small, big, 0 to 9, underscore, and character that's used in words in other languages, all right? So that's an exact match, right? That's the exact match, okay? How about 2? There's no match because it doesn't have the dot in between, great. And the third one, exact match, only for Python and some programming language, all right? Awesome. Wow, we're so quick, we're proud of us, all right? Character grouping, so you know, the backslash W, backslash D is already grouping, but sometimes you want your own customized group. So for example, you might want just A, E, and I. You could use the square brackets to specify the set for that single character, only one character, all right? So this set means it will match just one character. So for example, I did my thing wrong. So this regex, B, D will matches bad, bed, and bid, okay, and nothing else, okay? Because we specify the set to be just A, E, and I. You can negate it as well. So, it's a complement of this set, all right? So in this case, if we put the caret inside the set, it means the negation of it. So this will match B, C, D, B, D, D. B, E, D would not match because it's in this set. B, F, D would match because F is not in this set. Okay? All right. Next, vertical bar. Vertical bar means or. Okay? So that means A, or B, or C. So it would, if you had a regex like BEA or OOK, it would match BEA, that whole thing, and OOK, this whole thing. Range, you use dash, okay? You can use dash with the number as well. So this will follow the Unicode chart. So a Unicode chart for English already arranged alphabetically A to Z or big A to big Z. So it's already sorted, all right? So you could specify a range like this as well. Or you can specify multiple ranges like this one. And for Thai, yay. So for all Thai characters, you should memorize this one. It's Go to Garan. Because Gokai is right here, and to Garan will go all the way to where's the Garan? Garan is next to the dot. This one, is this Garan? Yeah, I guess it's Garan. It doesn't look like it, but it is. Okay? So that's awesome because why? It's not Gokaiถึง Honu Hook because we want the vowel as well. So if we want just the Thai text, we would want all the vowels here. You could also do Gokai to this little thing, which I don't remember what it's called. But then you get the Thai numerals as well. If you want, in some cases you will want that, but again, up to the use, right? But for the most part, we will have Gokai, Go ถึง Garan. It's quite easy to remember, Go Garan. Okay? So that's a special thing for Thai. If you want to select just Thai text, that's the regex that you want. If you want multiple things, we specify the set of characters now. Now we want to tell how many of them would match. So plus is means greater or equal to 1, star greater or equal to 0, question mark 0 or 1, so it means optional. We use these two a lot actually. These four exactly thing, we use that sometimes, but it's so ugly. So we don't really use that unless we. So at the end of the day, regex will look really ugly because it's just a bunch of symbols and it's impossible to understand. So that's the bad thing about it. But yeah, usually for the quantifiers, we use these two, okay? That we see a lot, these three. Again, you can always look it up. Put it on your notes, you can always look it up. Let's do exercise because tables are boring. See, now you know what I mean, how regex is impossible to read. If it's impossible to read, one thing you could do, copy it and paste it on ChatGPT. It will explain it to you in great detail. Do a better job than me, really. But let's do this. So, what does this word mean? Word character at least 3, right? At least 3 word character, including Thai characters as well. This is escape, right? \dot, we saw that. And this is one single character, that's a word character. At Jula, and this is the escape. So this is actually the actual pattern in Jula staff email address. It follows its pattern, which is awesome. Okay, let's play the same game. The first one is my email address. Exact match, thank you. The second one, no match because we require it to be at least 3. So we use a quantifier here, right? Yeah? What about this one? Some people shake their head. So yeah, no match because this part would this match? W would match the numbers too, right? Shit. sorry. See, I don't even remember. It will match number as well. It will match number as well. So the first part is fine. No, not fine. There's no dot. So it's already not a match. Okay. The fourth one. What do you think? The fourth one? No match because we don't have this part, right? Where there's a dot and a character. That's in the word. What about the fifth one? Okay, any answer? Partial match. Okay, so it trips on this part, right? After the dot, there must be only one word character, but this string has two. The second part is okay, so it won't match at all. Okay. Yes.
How do we differentiate between partial and match?
So okay, good question. So if I have something like this, say, like what would be a good example for that? Say, or like all right, okay, let's look at the new one. This is a partial match because it would match only this part, right? Only part of the string, not the whole string. Because W here would not match dot, right? Because it's not part of \W. Does that answer the question? Because this will cover up to here, right? And that's correspond to this part. And the dot here is okay. And the \W at this won't match at all. Okay, so partial match, I meant partially on the string, but that whole pattern needs to apply to the string. Okay, good question. All right, cool. So now I would like you to work in at your table. We have to write a few regex here. Let me tell you 3 regex that you have to write. This part, okay? RT, because whatever we retweet will start with RT and blank. Then I'm reading out the pattern to you, huh? So I want this part out, okay? RT at followed by the Twitter account and colon. So this part should be out. And this part should be out as well, the URL, okay? And also the handle at the end, via and handle at the end. So yeah, write 2 regexes or 3, up to you. Yeah, you can do one here for the URL, and the third one here for via at, okay? Write 3 regexes so that we can remove these. We can match them and remove it, okay? So at the end, when you apply it to your data, it should look something like this, okay? All right, I'll give you 10 minutes maybe to come up with an answer. James and I will walk around in case we have questions. If you are already done, yeah, let us know. We will look at the answer. I'll keep this slide up here. All right. Talk to your group. Let's say yes. Okay. So here's the answer. So I got 3 regexes over here, right? But I used them, Python code to clean it out. But yeah, let's look at the regexes. So first one, there can be more than one answer. So if you test it out and it works, and that's great. I would make it a little bit nicer here and put the caret here, because the RT would be at the beginning of the string only, right? And then add is add, and then Twitter handle, I think it's a \W, so it just, I think only alphanumeric, so alphabet and the numbers, right? And plus means at least 1. I think Twitter handle must have minimum length to it, but I don't know. It might be 6 characters. Yeah, but plus is okay here. And followed by colon and a space, okay? And the second one, you could do something like this for HTTP. This is very rough. You could make it tighter than this, but I write it a simple way. Okay, so HTTPS, sometimes it's not HTTPS, so I put the question mark here. Okay, colon // and I again use the big S, which means anything that's not white space. Again, you can do the set thing, or you can do the alphanumeric, because the URL link has its own pattern, or you can put t.co in there as well, because if it's on Twitter, it's always a t.co to make a shorter link for you. Okay. So yeah, there can be more than one correct regex. And for the last one, I should put $sign here too. So via, I think W would be better too. Mm-hmm. Yeah, so some word characters, at least 1, and it should be at the end of the string, because the via usually show up at the end, right? Okay. As for Python code for this, you could use this module, which I would not talk about because you can always look that up. The regex module, which is import RE, and I use this function .sub. So I will substitute this regex with empty string. That means it would delete, okay, from this string. Delete this pattern where you find it with empty string. That means it would delete. Cool. Something like that. Something like that. That's all I'll talk about regex, okay? So it's a way to extract patterns of characters that you want to match in the string, and we use a lot to clean language data to select just the part that we want. Again, it's ugly. It's not the sexiest thing to do because we want to do like LLM, machine learning, AI stuff instead of cleaning text, right? But this is a very good basic to have, and it's actually quite practical. All right, let's look at some actual data. What else would happen with your data? The thing with language is that you cannot really, language is language, and it depends on the users, right? User can use it in any way that you want, and that's the beauty of language, because it depends on the person that uses it, how they want to express, they want to convey the meaning, to express themselves, to establish that identity, to establish their belonging to certain group. So we use language for a lot of reasons. That's why language looks very different based on the social context and the media that people use. Speaking of media that people use, so nowadays you see a lot of non-standard language because now people are allowed to express themselves anywhere on the online platform, Twitter, Facebook, Instagram, TikTok, blog post, basically anything, right? It's a nice data stream that we always get, right? Because it's cheap and it's up to date. You know, it comes, it streams in every second. And yeah, and it's also a unique context for language variation. Because on Twitter, we get something like this หัวเราะต้อนรับชาวที่ฉดใช้ emoji. And this, we can tell people, hey, can you use a proper Thai to write things? Because people are people and language is language, you know, it's alive, right? Another one แบบนี้คืออะไรอ่ะจะบอกว่าไม่จบให้เห็นหรานะครับ so you have to really read it out loud to actually understand this. This is a tweet from a long time ago. You might not know who these are anymore, right? I'm sure you know. Is this Rosé? No. Yes. Okay. I kept this a long time ago. I forgot who this is. This is Rosé. Okay. จุ๋มเหม่งมีอะไรจุ๋มเหม่งมีอะไร You really have to read that out loud to know the meaning. Beautiful. Language is beautiful. อันยองค่ะดูหนังสนุกนะ with many saraas. Great. I mean, these are real data that that you cannot really control how it's going to turn out, and we have to process and make sense of the data as well. Oh, another one. พระเอกซีรีส์วิตาไม่เอกแอนยอยักษ์กรัน I'm sure we all know that it's สอเสือกรัน right? I don't. I like รถเมย์ I still don't know it's ลอลิงกรัน or not. รถเมย์ is ลอลิงกรัน right? Who knows these things, no? Yeah, so yeah, these are so to say non-standard language, but we'll see that a lot, and it's quite normal. It's so normal that we don't think it's a non-standard anymore. So for NLP, we used to think for a long time that we should correct all of these things, but it's 2025, we won't correct these things. We just let it go because the model should be smart enough to understand this because people can. And model is really smart now, so we will not do anything with it, and we treat it as the nature of language, which it is. Okay, we bend it to intention, we bend it to how we want. Okay. Obviously, there's a lot more to say about how language turns out this way. So social linguists list a bunch of factors that would influence how people use the language, but that's not quite the scope of this course. But yeah, we'll accept that the so to say non-standard language is a normal thing in data. All right, issues with text data. So we clean it. We understand that if it's substandard, it's the way it is, and that's fine. But how do we process them now that we get to this point? Language is a hard thing. That's why NLP is NLP, because we need special things to take care of the data. I'll say vision. If you know about computer vision technology at all, it's a lot more simpler because image data are a bunch of pixels, right? So one pixel is a color of sort, and you put these pixels together, you have a picture, and that's awesome. But language is not just string pushed together, it's not just words pushed together, because when they are together, they have other properties that would change the meaning of it. So to analyze the language data, we think about structure. So we call that linguistic structures. So we look at many different levels. So the outer level, we call it a discourse level. So when the sentences come together in a context, it has different meaning, okay? Because when sentences are pushed together, they influence each other because they provide context for each other to understand. So some model would process the text at text level, at the discourse level, okay? So that's the biggest unit. So if you look at the smaller unit before we get there, we look at syntax. So that means sentence. So in some contexts, we look at one sentence at a time. For example, machine translation. For the longest time, including not now, we have LLM and stuff now, but if you go to Google Translate, it still do it at the sentence level. So it look at the text that you want to translate, parse it into sentences, and translate one sentence at a time. So that still happens. And lastly, morphology, we look at words, because word is the smallest unit that still makes sense, that still convey meanings. Okay, so in linguistics, we usually talk about these 4, 5, 6 things. We talk about discourse and pragmatics. That means the meaning in context, usually the whole text, right? Then we talk about syntax, which is just sentences. We look at one sentence at a time. And we look at morphology. That means you look at each word at a time. So it's different level of analysis, which require different models for. So we'll look at some today. And at the end, in the inside is sound, phonetics, and phonology. We will not talk about it in this class at all, but you could imagine the speech technology. When you talk to Siri, it will have this kind of model where they change where they relate sound wave with a string somehow, right? Okay, let's look at the common things that you definitely would need to know. In NLP, we call this process linguistic pre-processing. We use linguistics because words are linguistic units, sentences are linguistic units, all right? And pre-processing, that means you will process it before you do anything with it. So again, still not very sexy, but it's something that we use all the time. It's because it's the first step. That's looking at word segmentation. Word segmentation, there are many ways to do it depending on, that's a trade-off. Okay, we are in engineering. Engineering is mostly about design and trade-off. All right, so we will look at that right now. First, we have rule-based word segmentation, which is, we'll look at that at the next slide. All right, let's look at words, right? Words are, sorry, Thai words again. Next time, I'll have some English example as well. How many words are there? So we have to be clear about the unit that we use, right? So that we know what the correct answers are, so that we know whether a model is the correct one or not. All right. สวัสดีครับ is how many words? 2 words. What are they? สวัสดีand ครับ Okay, cool. We all agree 2 words, yeah? Also, don't confuse words and syllables, okay? I thought somebody would say 3 syllables, 3 words. Only 2, okay? Next one, ตัดหญ้า how many words? 2, ตัด and หญ้า great. What about ตัดใจ? Okay? It's like a คำผสม, right? That we learn. That's a คำผสม, right? Okay, so this one it's not clear. Now it's not clear, right? It can be 2, it can be 1, depending on how you think of it. คิดถึง 1. Okay, all right. It's not คิด and ถึง. Okay, good. What about คิดมาก Okay, all right, okay. We can think of mark as an adverb and kid is a verb, so there are two different words that make a phrase, right? What about เดินทาง Definitely one word, right? They are very different meaning, not compositional. สร้างทางนะครับ Two, so you build a path, build a way. Okay, that's great. All right, okay, what about on the right? ตู้เย็น It's one word. ตะกร้าผ้า Ooh. Maybe two, maybe one. Okay. What about ขวดแก้ว Sounds like two, right? Okay. What about หมอฟัน หมอฟัน seems like one. What about หมอดู Also one. Okay. What about What about หมอกระดูกOkay, หมอกระดูก is two, หมอฟัน is one. Great. Okay, so I just want to demonstrate the complexity of all this, right? So like that's why linguistics is important when we talk about these things, because then we are clear about the concepts. So for Thai, so the right answer that we think are right? But because there's no real good answers. These are the answers that linguists give you. So they say if it's not generative, for example, they'll say หมอฟัน is two words because you can have หมอตา หมอคอ หมอหมา หมอปลา what have you. So it's still generative. You can make more words from หมอ as in an expert, right? So usually we decide based on this kind of criteria. So yeah, there are many criteria out there. So when what you learn in high school, in Thai class, we have คำผสม and คำซ้อน right? Something like that. So that's another criteria. Again, no right or wrong answer because it's just a bunch of string once again. Okay? So yeah, we decide on some criteria and then we roll with it. But life can be good though. English segmentation is so easy. We can write regex for it. So for example, it might not be that easy. Let's see. Got a long list of ex-lovers. They'll tell you I'm insane. Yeah. What would be a good regex for splitting? So now to write this up, you only have to write the regex for the separator, or we call it delimiter. So what's the pattern that's between the words? Space. Okay, great. What about this thing? Space and comma. Okay. What else? What about this? Is I'm two words? I'm should be two words, right? I am, right? Oh yeah. Okay. All right. So maybe comma as well. What about this one? Yeah. Okay. So all punctuations. You can like write out all the punctuations and space and what is this thing? Ex-lovers. Is ex-lovers two words or one word? How about ex-boyfriend? How about ex-girlfriend? So yeah, it depends on on the analysis, but usually they think of that X is so productive because you can make many, you can be ex-student, as in you studied with me, you are my ex-student. So yeah, it depends, but usually for English we separate it. Okay? So yeah. You can write rule-based, as in you can write regular expression for it. And thankfully, you don't have to because you can use some tool to do that for you. So that's just awesome. I want to show an example if English doesn't have space. Can you segment this? Yes, the men die here is such a weird sentence. Yeah, so it turns out English, if you remove all the spaces, impossible to read. Thai never have spaces, very easy to read somehow, okay? Because the way the writing system was designed, blah, blah, blah. Thai used to have spaces, and then they disappear, and people don't struggle to read. So now we have Thai script that we have now. Just because. Okay. So if you want to do this, we do this for Thai as well. This is what we do for Thai. We use dictionary base. So we segment words based on the words that we know. You know, for example, you can segment this because you know the words that you can form in here, right? You know, like there's there's like them, there's theme, the men, mend, die, in. You know, you have knowledge of the language already. So if you have the vocabulary of that language, you should be able to segment it into words, English included, Thai included. So like any language, you can use this algorithm to do that. If you remember algorithms, which I'm sure algorithm is your favorite class, it is hell. Algorithm class is hell for all CS, all computer science students, me included. When I was a student, I thought it was very difficult. But again, we won't talk much about the algorithm here. But there are two algorithms that you can use the dictionary for. The first one is greedy. What's greedy? So first find the longest word in your vocab that match the string. So for example, the men die here, I think theme is the longest word you could match. You are already wrong, which means if you make a mistake, then it's gonna affect.
Shouldn't it be using the shortest word and use that as the optimal solution for the subproblem in the greedy algorithm instead?
The shortest.
Yeah, shortest word. That's our dictionary, and we define that as the optimal solution instead of the longest word. Will that be like better performance?
For this one, yes, right? No. For this one, no. Then you have then you have me, and you have. If you don't have anything in the vocab, you would just say just until you find the match. So you have just n alone, and you have dine, and then you have here, and you have he, yes, and you have re. So it won't be that great. Do you guys remember dynamic programming? That thing is so hard. That's what we are using here. Okay? I'm not asking you to understand it, but we're using dynamic programming, just so you know. So basically, we try to maximize the length of substring that match to the dictionary. Okay? I have an example, okay? So if you do greedy thing, what you get is this, theme, die here, right? Because it's the longest, and you have no other choice. So you have just n, and then you have dine, because you have no other choice too, and then here, okay? Because first you have three choices, right? But theme is the best thing you could do because it's the longest. But at the end, you have really bad segmentation. Okay. What about this one? So you do branching, like tree branching thing in a smart way, dynamic programming. If you want to know what it is, go back to algorithm class note, okay? So we'll go with we have men die here because we maximize the substring that matches it, okay? Yes?
So we did not learn the greedy, the DP, the verticalization, the tokenization. We didn't learn any of that.
Good for you, because it's so hard. Again, I'm not asking you to understand the details, just wanna, so that you see the difference between the two. But you can see that greedy would be very fast because you match the longest and you just go down this path right away. But if you do maximal matching, you have to consider everything, okay? And we choose this path because everything matches with the dictionary. If we choose this path, then it won't be optimal because N and E doesn't match the dictionary. If we choose this path, this is also not optimal because E and E don't match in the dictionary, okay? But we do it fast using a nice, smart algorithm. All right, so that's what we use. That's what we use for Thai as well, and it works really well, like 90%, 88%. So that's just awesome. So all you need is a dictionary, which means the list of words. How do we get that? How do we get a list of words? Say for Thai, where would you get that? So we go to some online dictionary, Longdu or Sanuk or something that have the electronic dictionary. And then you email them and say, can I have a word list? They might say yes, but somebody did that for us already, okay? So we have the word list, but usually we have a digital dictionary of sort for all languages, for all major languages, because there are some other that don't have dictionary, but mostly we would have it. So it's not very hard to get that actually. Okay, so get a good dictionary, okay? And yeah, use maximal matching and it would just work. Somebody implement that for us already. We only have to put in a list of strings and it would work. So, example. So ป้ายกับรถ We did not get ป้ายกรถ okay? We did not get ป้ายกรถ because we prefer each word to be long and in the entire string to match the dictionary. In this case, we are ambiguous, right? Whether we should have ป้ายกรับรถ or ป้ายกับ very hard to read, or ป้ายกับรถ because we maximize for the length of the string in each one. Okay, so we would prefer this one. So that's the right behavior. เดินหามเหสี okay? So we won't say เดินหามเหสี although they're all in the dictionary, หาม, right? เห as in go a different way and see as in the color. So we would prefer this one because the algorithm would prefer the match that are long for each word. Yes? Okay, good point. Good point. So how would it handle what the crush? What the probably not in the dictionary. So what we could do, the best we could do is what, right? And then the, right? And crush all in one word because they all did not match. So we clump them together into one word. So that's the behavior you would get from what the crush, okay? So you get 3 words, what, the, and crush with the long sh. All right? So it would do something reasonable-ish, as in not very, but it tried its best. What about, it's not even a word anymore. I know it's like 5 years ago. I made this slide a long time ago when people used this word for like 1 week, right? How would the word segmenter work on this? Did you see any string that would be a word? Any substring that would be a word? None. So it would say this is one word, which is correct actually. Not bad, not bad. So if a word that's not in the dictionary is sandwiched between the words that are, then if you will have that behavior. Yes. Misspelled the same way. It will be treated the same way. Not great, right? It's okay, but not great. So, but we still use this because it's fast, right? Next, next we have machine learning. Machine learning, so that means it would learn from data. We have done machine learning. So what happened is we hire a bunch of linguists, usually undergrads, junior year, working for me. I ask them to do these things. So I give you a text, please analyze it and parse them into words. So you have some samples. Once you have those samples, you feed it into some machine learning algorithm, which we will actually learn in this class. It's very special. So that it learns how to segment words. So it will learn from the data. So this one works much better than dictionary-based, but again, requires to do this to get the training data. But the good news is, we already did this for you, so you don't have to do it anymore. Somebody already did it and shared the data with everybody, and even train the model for you and make it open source. So we don't have to think about it anymore, but so that you know the source of it. So this is my own paper from 2001, 2021, seems like eternity ago. So if you compare the performance, this is the higher the better. The dictionary base, you get 70%, which is not that bad actually. But if you use deep learning, use machine learning, you can get 90 up kind of performance. And if you move to Twitter data, ISE is Twitter data, so a lot of misspelling, typos, non-standard language, so to say, it dropped by a lot, but still 84. And dictionary base, in this case, somehow does better, which is okay. But machine learning will still do much better, 80-something%, which is great. And TNHC is the historical corpus, that means old Thai or poems, Sunthorn Poo, Nirad and stuff. Okay, so so it's gonna be a lot worse, right? So it's, a lot worse. But for dictionaries, it still does okay. It's quite consistent, and you still see another drop from machine learning. But 70-something% is, again, not that bad, because we train it on standard data. When we apply it to poems, it's not gonna do well. And it did not do that great, but still not ugly, all right? And accuracy come at a cost. So in this graph, the x-axis is the execution time in seconds to segment 2 million characters. 2 million characters is not a whole lot. It's a lot, but it's not that many. Yeah, but it's still, what is it? 800 something seconds to parse, to word segment 2 million characters. 800 seconds, that's some time. That's what, how many minutes? 10-something minutes. 10 minutes on the computer is an eternity. So, right? So so if you have a lot of text, sometimes we don't use this kind of model anymore. But the model that I propose in this paper is 10 times faster than the previous one. So it used 90 seconds to process 2 million characters. So a minute and something, it's okay, you run it, play with your phone for a bit, and it's done. So it's not that long a wait. But if you compare to dictionary base, it takes 7 seconds. So it's still 10 times kind of different. 10 times kind of difference to use machine learning model versus the vocabulary based, dictionary based. So if you have really a lot of data, dictionary based is totally fine if you want the speed. Oh, by the way, this is run on like a normal machine on a laptop, so not something fancy. Okay, let's look at some code to segment words. This is all very easy. So you import a library, you know how to install the library already, right? Pip install Python NLP, pip install Attapol, which is a library for cutting words. Attapol is from Attapol, all right? My student came up with this clever name, so Attapol, Attapol, and we don't have a lot of resources, so I thought it was nice, but now I'm stuck with it forever. All right. So it will download the model for you, and you only have to set the engine to Attapol, and it will use the machine learning model to segment words for you, which is awesome. For example, รักทางดีไม่ตีก็ดังแต่คนดีไม่ต้องตีมันก็ดัง I know, it's a moral that we will learn today. So it did, it makes a mistake. ตีมัน definitely two words, right? But it makes a mistake. And then once again, it's machine learning. You don't know why it makes such a mistake. All right. พระมหาไพรวันถึงกับต้องบอกให้เจยิ้มแบบอรุ่มเจาะอีกรอบ พระมหาไพรวัน has no way of making it into the dictionary that you want to use for your word segmenter. So in most cases, we'll use machine learning, actually, if you want the accuracy. And it did that beautifully. พระมหาไพรวัน is one word, who's no longer. You all know that. It made a mistake here, JJ Yim. That's a cool name. I want that to be my nickname. JJ Yim is a great name, but it makes a mistake here, right? Arum Jo, it got it right here. So that's cool. So it can handle the words that it hasn't seen before. Oh, for English, I just give you the code once again. NLTK download. You have to run the download, so it downloads the tokenizer, and you don't have to do anything. Just call word tokenize, and it will do it beautifully. Just so that you see the difficulty of it. U.K. is part of the word as well, right? UK is one word, and it can do that. $1 billion. It split the dollar sign and one, which is the right thing to do because dollar sign means dollar, one means one, right? So it splits that for you. So it considers many things, not just the spaces. But you would know it's a bunch of regular expressions. Cool. That's word tokenization, but I need to teach this one because that's what we use now for all large language models. ChatGPT, GPT-4, Claude, Gemini all use this kind of tokenization. Why? Because who has time to look at each language individually? So if I want a model to work on 100 languages, I have to look at 100 languages and build 100 models for that. Who has time for that? These people, Google, OpenAI, they have bigger plans than that. So we want a model that works for all tasks and all languages. And it worked, right? We see that it worked. It seems like a ridiculous thing when I say that maybe 5 years ago. Now they did that. And also modern NLP models can tolerate bad word segmentation. So you might get 20% wrong on word segmentation, and it still performs well. So with what we know, we think that we can do a really bad job at this. We want the speed because why? If you want to train large language model, you want to tokenize the whole internet. And you know how big the whole internet is, right? It's like billions, trillions of tokens. So trillions is aล้าน unit. So it's a lot, more than you could imagine, actually more than like many libraries combined. So that's a lot of tokens. So to be able to do all that in all languages, you need something, we call it quick and dirty. So it's quick and it's also dirty because it does a really bad job. Okay, so this when it gets interesting. How bad can we get it? How bad can we get it that we can still not too bad? So when you want to get it when you want something really perfect, it's quite easy. Something really bad is also easy. But if you want something in the middle, that's when it's hard. And they figure it out, okay? So they call, that's some common algorithms we call subword tokenization. So which means a token, we call that a token now. That means a unit that we want to work with. Because a token might not be a word anymore. It can be just about anything, okay? So to demonstrate that, I think OpenAI do have tokenizer demo, if I'm not wrong. So this is how OpenAI tokenize things. Many words map to one token, but some don't. Indiv, and then isable, okay? Which is interesting, right? Because isable can be a suffix, right? Because you have invisible, divisible, indivisible, so it could be a suffix. So yeah, with that in mind, they want something like this to help with the words that you haven't seen before. Okay, let's try with their own text right here. Oh yeah, look at the numbers. 1, 2, 3 is one token. 4, 5, 6 is another token. 7, 8, 9 is one token, which is great, okay? It doesn't make any sense, right? But yeah, that's what it does. They don't even have a rule base to process numbers, all right? Whoop. Okay. Okay, here, program and matic. Matic, is matic a suffix? Ic is a suffix, right? You have automatic, magic, a lot of ic. Mechanic, right? But matic should not be a suffix, but they said, sure, let's break it into 2 tokens. That's why we call it subword tokenization, because a word as we know it will have more than 1 tokens now, like programmatic, okay? Or JavaScript, now 2 words. Java and script is 2 words. Community supported is community, and then dash supported as another token. Ooh, yeah. Okay, so it's something like this. So it's something messy, but not that messy. All right. Let's me pick some text from, let's say, the standard. I want to show how it tokenizes Thai text. Let me get some samples. Sure. This is just random Thai text, you know, I don't have opinion one way or the other about Phum Tham. Just want to show you. Okay, so some standard Thai text, and we want it to tokenize, and it's going to be fun if it does it correctly. Oh, wait. Okay. Let me restart it. Okay, cool. Here, กระทรวงมหาดไทย, how many words are there? Either 1 or 2, right? It's gra and tr, wong, maha, art and Thai. Not great. นายกรัฐมนตรี I and เกรัฐมนตรี. terrible. Nonetheless, it performed beautifully on time somehow, okay? So 500 something characters to get 183 tokens. All right, so obviously it does an awful job tokenizing, but paired with the model, it still works okay. So they do something right there. Cool. All right. Can I cover this in 25 minutes? I bet I can, but we'll continue to, next week. Okay, so subword tokenization. So you see the demo of how it does it, right? So it does a poor job, but not that poor of a job. So it has two parts to it. First, it's basically a dictionary base. It's a dictionary-based tokenization. So first, you have to learn the vocab from the data so that you get the dictionary out. And then you do word segmenter using that dictionary, which we already learned 20 minutes ago. Okay? So the hard part is about getting the vocab for every language on Earth. That's what they did, right? So a version of this is called BPE, or Byte-pair encoding token learners. So first, we have a dictionary with just individual characters. So A to Z, กอไก่ถึงฮอนกฮูก and all the Chinese characters, Japanese characters, everything that's on the Unicode chart basically can be included in this. Emojis is also in the tokenizer. So here's how it works. Once you have that, you find the two characters that appear together the most. Okay, so assume that it's A, B, okay, big A, big B. Then you treat A and B as one word. Okay, it will start building up from here. Okay, so once you merge it, then you have a new vocabulary. So you add A, B into the vocabulary. And then you do this again and again. Let's look at an example, actual example. Okay, suppose you have this corpus where, so you have low, lowest, newer, wider, and new. And low you find 5 times, lowest you find twice, newer 6 times, wider 3 times, and new twice. Okay? So at first, your vocabulary is just all the characters that you see in your data. Usually it would be very large, right? But for this example, we only consider these. So ER, you found that they occur together the most, which is how many times? 9 times, right? So in here and in here. But this is 6 times, this is 3 times, so 9 times. So we combine them and think that they are the new word, okay? And then next iteration, we do it again. See how we change E and R to be one word together. And we did what? We add ER to the vocabulary. Again, then we find the two tokens that appear together the most. So it turns out an ER and the end of the word. Okay, so we add ER at the end of the word as the new vocabulary because we found that 9 times. Okay, so we have new word in the vocabulary which is ER that ends the word, and we keep doing this. So next one apparently is N and E, which we found 6 times. You have to trust me. That's the most frequent pairs of tokens that we find. So which is 6 times. So we're gonna merge N and E, okay, and add NE to the vocabulary. So we see that we start adding something that almost makes sense. This is the suffix, right? ER to make adjective into a comparative form, the ER form, And you kept doing this again and again and again until you reach the vocabulary size that you like. Okay, so it's just a bunch of for loops. Okay, so now you might wonder, why do we get so few? Why do we have such a crappy dictionary for Thai? We don't have space, that's one, but it's mostly because Thai account for 2% of their data. So Thai text hardly get merged. So English text would get merged a lot and build up into something that looks like a word, or something that looks like a suffix, something that looks like a prefix. But they don't process Thai very much. So their vocabulary is already full before we can merge more Thai characters into a word. So now we have LLM that's more like Thai focused. We have Typhoon. I think Llama does a little bit better job, but I haven't checked. But yeah, now we try to fix it as well.
Why us humans can tokenize Thai like seamlessly? Why can't we mimic our thinking method to the AI?
So the question is like, why can humans segment words in Thai so well, and machine doesn't? So that's a very good question. So humans use a bunch of things. So we use a vocab as well. We use a dictionary for sure, but we also run into the words that we haven't seen as well, right? But we did learn the pattern of how things should sound in Thai. So we learned the rules, the orthographic rules, and the sound rules for Thai words. So Thai native speaker can sound it out, can like read it out and see if it sounds good. So that's one, and that's quite hard to make machine learning model that would do that. So maybe we would need more data for the machine learning to work well for that level.
So we have more metrics on the pronunciation and the common sense when we pronounce it.
So we use the context, the meaning context as well. We use that, but we also use the spelling rules. So like Thai words can only say, for example, you cannot start a word with sara a. No, we know that rule, but we can make a machine that do that as well. But yeah, there are other patterns that are hard to capture by the machine. But yeah, humans are very good at languages. I think that's the short answer. Okay. So if that part is done, we have the dictionary. Then it's very easy. We use the greedy algorithm that I told you before, match the longest you can, and it will do good enough job, not so bad, okay? And we could use maximal matching, which we used before, which is not greedy, which is optimal. Why do we use longest matching instead? What do you think? Yes. Fast. That's it. Yeah, because you have to tokenize the whole Wikipedia. You have to tokenize the whole internet. So their only choice is to do this, or they will wait forever. Okay. Cool. So longest matching, just to remind you, is this one. Okay. Theme, dine, and here. Not great, but good enough. All right, so if you look at, I showed you the example already. So the dictionary, if you train it properly, it will include the words automatically, which is awesome, right? So characters that appear together in a word usually appear together a lot. So that's nice. They also found like prefixes, suffixes, which is great. So if you have the words that you don't know, then you can pick out the suffix still. Okay? Yeah, so yeah, we call these things morpheme, prefix, suffix, so it works actually okay, not too bad. All right. Yes. So to summarize, right, word segmentation, tokenization, we learned that there are 4 ways. So we have rule-based, which works for a lot of languages. It's quite simple, quite accurate, okay? But there are many languages that don't have word boundaries. Actually, not that many. Do you know? Okay, Thai doesn't have word boundary. Doesn't have word boundary. What else? Chinese. Chinese doesn't have word boundary. Japanese also doesn't, and Korean. And our favorite neighbor, Cambodian. Also our favorite neighbor, Burmese. I think there are around, handful. You can count them, the writing systems that don't have word boundaries. So TypeScript is really cool, guys. We don't have word boundaries. That's always the first thing I tell people. Like, see, there's no spaces there, and that's awesome. So, which means you cannot use regex for not many languages, just a few languages, but those are very important languages. Chinese, very important. So we want to be able to process that as well. Next, dictionary based, you only need a good lexicon. So that's great because lexicon, you can always change it. If there are new words, you can throw it in there. You can update the dictionary because it's just a file and then it will work better. But it's not generalizable. So if you see a new word that you haven't seen before, it will do quite poorly. And in many applications, you see unseen words all the time. Next, ML based, which is awesome, but you have to train ML model on the samples that you segment words by hand. So this is the best option, actually, best option available right now for languages without word boundaries. So the 6, the 7, the neighbors that we hate, our language, and East Asian, so CJK, we call it CJK, Chinese, Japanese, Korean. That needs ML-based algorithm. And we have the ML-based word segmenters for all those languages, including Khmer. Khmer is Khmer in English. But it's slow, and you have to create the training set for it. So we don't do much for that anymore, I think. And lastly, we have subword tokenization, which we need a lexicon, but we can train it quite fast on the corpus. And it's super fast, but the results are not always words, but sometimes we want to analyze words. So, almost ran out of time. I think we can wrap up here. So, to conclude, basically, word segmentation, if you look online, there'll be people who say, oh, word segmentation is so hard. Thai is so difficult because we cannot segment words. Word segmenting is very easy now. It's not really a challenge for NLP. The challenge for NLP now is to actually understand a big chunk of text. So word segmentation is a non-issue. So I hope you understand this part now. But when we want to be accurate, now you know other solutions. We have many ways to process the data when it comes to tokenization. Yes. Yeah. Would it be expensive to run? So the question was, why don't we use good word segmenter for LLM, right? So the answer is we do now. So if you have heard of like Typhoon or like other more Thai-centric large language model, they do actually train really good tokenizer for Thai using BPE. So not using the ML base, but using BPE, they could get pretty good result. So we do use a good tokenizer, but it's still a fast tokenizer. Again, you won't get words, you would get subwords sometimes. Okay, so next week I'll let you play around with some of the tokenizers and see different behavior. Okay, and that's for next time. and we'll finish up sentence segmentation and the rest. Okay, and yeah, check Courseville next week because next Monday we don't have class normal time, it's holiday, so we'll have it on Friday, but I'll find a room and let you guys know where that would be. Okay, so I guess I'll return 10 minutes to you guys because you guys are so focused today, and I'll see you next week.